Alright, so in this problem, I have 2 to the power of 3x plus 2 to the power of x is equal to 10. So to start, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, 2 to the power of 3x, I can rewrite as 2 to the power of x to the power of 3. So now I have this plus 2 to the power of x is equal to 10. And now I'm going to let 2 to the power of x equal to the variable y. So now I have y to the power of 3 plus y is equal to 10. Now if I subtract 10 on both sides, I get y to the power of 3 plus y minus 10 is equal to 0. Now y I can rewrite as negative 4y plus 5y. I have this minus 10 is equal to 0. Now I'm going to factor this by grouping. I'm going to first factor out the greatest common factor from y to the power of 3 minus 4y, and then from 5y minus 10. So from y to the power of 3 minus 4y, the greatest common factor is y. So I have y times y squared minus 4, plus from 5y minus 10, it's 5. So I have 5 times y minus 2 is equal to 0. Now, y squared minus 4, that's the same thing as y plus 2 times y minus 2. So I have y plus 2 times y minus 2 plus 5 times y minus 2 is equal to 0. And now if I factor out y minus 2, I get y minus 2 times y plus, y times y plus 2 plus 5 is equal to 0, which is equal to y minus 2 times y squared plus 2y plus 5 is equal to 0. So now this gives me two equations. Y minus 2 is equal to 0, and y squared plus 2y plus 5 is equal to 0. For y minus 2 equals 0, y is simply equal to 2. For y squared plus 2y plus 5 equals 0, I'm going to use the quadratic formula. And I'm actually, if we just check b squared minus 4ac inside the quadratic formula, well, b squared, that's going to be 2 squared. So I have 4 minus 4 times a, which is 1, times c, which is 5, which is equal to 4 minus 20, which is negative 16. And you can't take the square root of a negative number, so there's no solution for this. And my only solution for y is 2. So now going back here, remember how we set 2 to the power of x equal y. So this means that 2 to the power of x is equal to 2. So 2 to the power of what number is equal to 2? 1, right? Meaning x is equal to 1. So this is my solution. Alright, so in this problem, I have 2 to the power of x minus 1 is equal to 3 to the power of x plus 1. So I want to find the value of x here. So for my solution, I first start with 2 to the power of x minus 1 is equal to 3 to the power of x plus 1. Now, I'm actually going to take the log on both sides. So now I have log 2 to the power of x minus 1 is equal to log 3 to the power of x plus 1. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is equal to b times log a. So in this case, I have log 2 to the power of x minus 1. I can move x minus 1 to the front. And log 3 to the power of x plus 1, I can move x plus 1 to the front. So now I have x minus 1 times log 2 is equal to x plus 1 times log 3. Now, if I distribute these two, I have x times log 2 minus log 2 is equal to x times log 3 plus log 3. Now I'm going to subtract x times log 2 on both sides and add log 2 on both sides, subtract log 3 on both sides. So then these two cancel out, and I have negative log 2 minus log 3 is equal to x times log 3 minus x times log 2. Now if I factor out x from here, I get x times log 3 minus log 2 is equal to negative log 2 minus log 3. If I divide both sides by log 3 minus log 2, I have x is equal to negative log 2 minus log 3 over log 3 minus log 2. Now, if I multiply both sides by negative 1, I get x is equal to log 3 plus log 2 over log 2 minus log 3. So this is my answer. Alright, so in this problem, I have x to the power of x is equal to 4 to the power of x plus 16. So the first thing I'm going to do is I'm going to take the ln, or natural log, on both sides. So now I have ln x to the power of x is equal to ln of 4 to the power of x plus 16. Now if I have something, if I take the ln of something in the form a to the power b, and I can move this exponent b to the front. So this can equal b times ln a. So in this case, I have ln x to the power of x. I can move x to the front, and ln 4 to the power of x plus 16. I can move x plus 16 to the front. So now I have x times ln x is equal to x plus 16 times ln 4. Now if I distribute the ln 4, I get x times ln 4 plus 16 times ln 4. Now if I subtract x times ln 4 on both sides, these two cancel out, and I get x times ln x minus x times ln 4 is equal to 16 times ln 4. Now I can go ahead and factor out x from here, so I get x times ln x minus ln 4 is equal to 16 times ln 4. Now ln x minus ln 4, that's simply equal to ln x over 4. So I have this is equal to 16 times ln 4. And now this is essentially saying that x over 4 is equal to 4 over here. These two are equal to each other. So if x over 4 is equal to 4, this means that x is equal to 16, because these two have to match up as well. So now to check, let me plug this in over here. So if I plug in 16 over here, I get 16, because x over here, 16 times ln, 16 divided by 4 is 4. So I get 16 times ln 4 is equal to 16 times ln 4. So this works. Now for method 2, method 2, to check, I have x to the power of x equals 4 to the power of x plus 16. X equals 16, so I have 16 to the power of 16 is equal to 4 to the power of 32. 16 is 4 squared, so I have 4 squared to the power of 16 is equal to 4 to the power of 32, meaning 4 to the power of 32 is equal to 4 to the power of 32.